If 2x cubed minus 3y squared equals 8, I want to find d squared y dx squared. You might remember that symbol from our last unit. We didn't really do much with the symbol, but I did show it to you. This is our dy dx version symbol of the second derivative. So I'm really asking you to find a second derivative implicitly. Well, obviously, to find a second derivative, we need to start by getting the first derivative. There's nothing new with that. You can go find the first derivative of this function. So I'm getting a first derivative of x squared over y. To find the second derivative, we need to go and find the derivative of the first derivative. So I'm going to go and take the derivative of both sides of that. I'm going to do the derivative of the left, and I'm going to go do the derivative of the right. On the left, this symbol just means the first derivative, so the derivative of the first derivative is the second derivative. I'm just going to write that d squared y dx squared symbol, but just realize it's just a symbol that means the second derivative. As for the right, I'm going to go use the quotient rule on this. It won't be easier to turn this into a product and use product rule, because we would have to use chain rule then that we don't really have to use here. So I'm just going to leave it, and I'm going to go low y d high is 2x, minus high x squared d low is dy dx. Draw the line, square below. This is all over y squared. I can clean that up a little bit. I can say 2xy minus x squared dy dx over y squared. However, when we're done, we really should have a formula for the second derivative that just involves x's and y's, not also dy dx. When I'm done, I should be able to plug in just a point and get the second derivative. I shouldn't have that dy dx thing there. However, I know what dy dx is. I found that up here, so I'm just going to go and replace dy dx with x squared over y, and then simplify what I get. d squared y dx squared should equal 2xy minus x squared times x squared over y, all over y squared. That's 2xy minus x to the fourth over y, all over y squared. We shouldn't leave fractions inside fractions. If I multiply this answer by y on the top and y on the bottom, I can get 2xy squared minus x to the fourth over y to the third, and that's my second derivative.